Hello, today we're talking about equilibrium in two dimensions. Equilibrium in two dimensions is mean the object in static. That's mean is the object is not moving. So, if the object is not moving, we use three equations. Sigma f of x equals 0 and sigma f of y equals 0 and moment equals 0. First, define the equilibrium. When a body in the equilibrium, the result of all forces acting on it is equal to 0. It's mean the sigma f is equal 0. It's mean sigma f of x equals 0 and sigma f of y equals 0. The result of force and the couple m are both equal to 0. It's mean moment, or we call sigma moment, equal 0. Modeling of object, contact and support. Type of contact and force origin. Fixable cable, belt, chain or rope. Here, weight cable negligible, as we see here, and weight of the cable not negligible, as we see here. Smooth surface analyzes the force just a norm, and in the rough surface analyzes the force in the x-axis and the y-axis. Here we see the roller analyzes the force in just a norm, and here we see pin connection analyzes the force in the x-axis and the y-axis and with angle. Here we see fixed support analyzes the force in the x-axis and the y-axis, and we take the moment. Gravitational attraction, we see W equal m multiplied by g. M mean is the mass and g is mean gravitational acceleration. Example of a free body diagram. Mechanical system of cantilever beam. As we see here, we have fixed support. If we want to draw free body diagram, we take the fixed support in the x-axis and the y-axis and take the moment around it. Additional of the forces, draw the all forces. Also draw the W is mean m multiplied by g. If we have a force acting on the object with angle, we analyze the force in two components, Fx and Fy. Fx is equal Fb multiplied by cosine theta, and Fy equal Fb multiplied by sine theta. Step for solving 2D problems. First, draw the free body diagram is very important. Define axis orientation. After that, define all reaction support. Next, define all external force, known and unknown. Finally, apply equilibrium equation. It is sigma fx equals 0 and sigma f of y equals 0 and moment equals 0. Now, we're gonna solve this problem. So the question say, determine the reaction at A and E if P equal 500 Newton. What is the maximum value which B may have for the static equilibrium? So he want the P max, and as we say before, this pin and this a roller. So in the pin here A, we analyze the forces as AX and AY, and in the roller we analyze the forces in EX, and neglected the way and for the static compared which the applied loads. Now we solve what he talked about of the problem. So he asked for reaction and of A and force in AX and AY, and asking of B max. So we use the equation. First we use the equation sigma f of x equals 0. So we take the force in the x-axis EX plus AX negative 4,000 sine 30 equal 0. And now take the second equation is sigma f of y equal 0. Up is a positive and down is a negative. So what have in the y-axis? First we have AY plus 500 Newton negative 4000 cosine 30. So we call this equation 2. So AY equal 4000 cosine 30 negative 500. So AY equal 2064 Newton. And now we take the third equation. It is sigma m equals 0, and we take the moment around the A. So sigma m A equal 0, and clockwise is positive. So in the moment we take F multiplied by distance. So EX multiplied by 3 plus 500 multiplied by 8 negative 4000 cosine 30 multiply by 4 equal 0. So EX equal 3285.4 kilo Newton. So we call this is equation 3. So now we substitute equation 3 in equation 1. So we can find x equal 4000 sine 30 negative by EX. So EX equal 4000 sine 30 negative 3085 by 6. So EX equal negative 1085 Newton. So now we have AX equal 1085 to the left. So we can now find the reaction of X. So the reaction of A is A equal square of AX. Now to find the reaction in A, take square root AX square plus AY square equal is the AX square is 1285 square plus 64. So A equal 3230 Newton. So when EX equal 0, so B equal B max. So now we take the moment around A. So sigma m around A equal 0 and clockwise 0. So we take 0 of EX plus B, and the distance is 8, negative of 4000 cosine 30 by the distance 4 equal 0. So the B max equal 4000 cosine 30 multiplied by 4 divided by 8. So P max equal 1732 Newton. And thank you.